Bergado, Eredina, and me, Dow. So our project is about the compact wind turbine generator. Our goal was to make something eco-friendly and familiar as well as useful to our daily life. We want to create the product that most people can access to. Simplicity is also our principal target. So we are living in digital age, right? It is apparent that most of like activity rely on electronic device like phones and laptops are the most popular and essential. Just imagine you will have an important phone call in 30 minutes and your phone is out of battery during the time you're commuting to the office. So our project was born to help you out. The product consists of three principal components: the turbine, the power bank, and the base. The turbine blades, which are built from the recycled plastic bottles, are connected to this DC motor. The power bank is attached to a motor which is connected to the blades. Hong, can you just switch to another slide? A clip-on is used for mounting the turbine on the window of the car. And when the customer drives on the road and the turbine will spin and absorbing the weight, the turbine will be connected to the electricity wire that will directly lead to the power bank. The wind energy convert into the electrical energy, which is stored in the power bank. And then the electrical power stored in the power bank can be used for charging the phones, laptops, or any emergency case.
And so this is the first ref for our concept. So first one, the first revision is like we're gonna have the fan is cutting from the recycle bottle, the 16 OZ, and then we're gonna cut to a plate, but then the base is gonna use also another bottle. But then after figured out like how should we put the bottle base into the top of the car. So I think we have a little trouble here. We don't know how to let the base, like the bottle base, stay strong on the roof. So we go with the second revision. So instead of the bottle, we find out that the clip-on bone for the flag is similar function like the fan we want to work on. So instead of using the base, we use the bone with the as the base, and then have the same have the fan like a plate cutting from the recycle bottle, and then we got a clip on the window. So for the schedule in Oron, we almost be on time for whatever we plan ahead. And this is the final week for the present product to the class. So far, we not too far behind from the plan. So for the experimental setup, I'm gonna talking about the turbine blade design. So as I mentioned before, like from the 16 OZ recycle bottle, we're gonna cut to a plate, and then we don't really use the neck or the top of the bottle. We just use the base from the bottom up, for the bottom down, and then the fan diameter is like 11 inches. And then we use the cap and we glue it to the bottom of the bottle. From there, we're gonna install the DC model, 5 voltage, 6,000 resolution per minute. And the cost for this model is like $699. Aaron, you want to go ahead with the support structure?
Yeah, so this was our second option for the main thing that holds everything together. It's this flagpole we bought. What we didn't, it is 17.5 inches, but what we didn't consider was the strength of the pole. So it is kind of flimsy. So it attaches onto the car window on the picture on the left, and on the picture on the right, you could already see that it's starting to, you could already see it drag behind when you start to drive. But it does work and it does get the job done. And yeah, it's a good second option. We just wish we got a stronger material. And these were the main components that connected everything together. The first picture is the booster circuit board, and that's what connected to the DC motor. And that had a USB, which was able to plug in any USB charger. And that charger would connect to the power bank module, power charger module on the right. And that would connect into the power bank, which is shown on the right picture. And that's connected by the positive and negative wires. And everything was connected together by the soldering tool. So basically how everything works is the wind turbine is connected to the 5-volt motor, which connects everything by the electrical wires. And everything, when the wind comes, it collects the energy and it stores it into the power bank. So the first video, we had 3 different tests. The first video is the making energy from the drive of 15 to 25 miles per hour. Yeah, so as you can see, it works pretty good. It's just that you can see it's kind of flimsy. It's like kind of moving back and forth, but it still works great. And then the second picture is like another demonstration is if you don't have a car, it still works with natural wind. Yeah. And that just shows how the cord is long enough so you could watch it charge while you're just sitting down as it collects all the energy.
That were discussed and possibly proven were Betts' laws, which indicates that maximum power can be extracted from the wind. Also, can recycled materials withstand air to produce kinetic energy? And how long does the kinetic energy take to produce a full charge in the power bank? And also the reliability of the power bank itself was in question.
So after several trials, we found that the product works really quite efficiently in terms of producing the electricity from the wind. It takes about 2 hours for the power bank to be fully charged. In general, under 20 to 25 miles per hour, the build can withstand the wind so well. However, when it comes to the high speed, such as 30 miles per hour, the flagpole is not strong enough. It flies back and forth. So we need a much more sturdy pole to make it up to 40 miles per hour.
And in conclusion, most of the entire project completion was roughly 90%, only because we did get to assemble and do small testing was completed, but we wanted to do other testing that we couldn't do due to schedule conflicts and time restraints. We also learned about basic kinetic energy and wiring. We learned that it does produce energy. and we missed the opportunity to explore other materials for the blades itself and